Okay, lesson 7.5 is properties of trapezoids and kites. Okay, so just some more shapes that we're going to learn some properties about. Okay, so a trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay, so then you have the bases of a trapezoid, and those are the parallel sides. Okay, so if I'm looking at this picture over here, this is a base, and this is a base. Okay, then you have base angles. Okay, and they are two consecutive angles whose common side is a base. Okay, so this angle, this angle, this angle, this angle, okay, could all be base angles. Okay, and then finally the legs are the non-parallel sides. So this is a leg and this is a leg. Okay, the last one is an isosceles trapezoid, and it is a trapezoid with non-parallel sides congruent. Okay, so you have the two parallel sides showing with the little triangle, and then the little hash mark shows that the non-parallel sides are congruent to each other. So that makes an isosceles trapezoid. Okay, so in example 1, it says show that ORST is a trapezoid, then decide whether it is isosceles. Okay, so the first thing that we need to do is prove that it is a trapezoid. Okay, so to do that, we are going to find the slopes of all four sides. Okay, so 4 slopes. Okay, so the first one I'm going to do is the slope of RS. Okay, so that would be 4 minus 3 over 2 minus 0. So that would give you 1 over 2. Then we're going to find the slope of OT. And that would be 2 minus 0 over 4 minus 0, which is 1/2. Okay, so those are the same slopes. So I know that those two sides are parallel, but now I need to figure out that the other sides are not parallel. Okay, so they don't have the same slope. So then I want to find the slope of ST. Okay, and that would be 2 minus 4 over 4 minus 2. Okay, so that'd be negative 2 over 2, which is negative 1. And then the slope finally of RO is 3 minus 0 over 0 minus 0, which is 3 over 0, but you can't have a 0 in the denominator, so that is undefined. Okay, or it's an up and down vertical line. You can think about it both ways. Okay, all right, so let's make a little line here so I can separate my work. So exactly one pair of opposite sides are parallel. Okay, so yes, trapezoid, trap. Okay, now is it isosceles? Okay, well, to figure that out, I need to do 2 distance formulas. Okay, well, I don't have to do the distance formula for RO because it's a straight up and down line. Okay, they share the same x values, if you remember that. We don't have to do the distance formula. Worst case scenario, though, you can just resort back to the distance formula because it's something that you know how to do very well by this point. Okay, so instead I can do 3 minus 0, or the absolute value of that, and you get that RO is 3. Okay, ST I do have to do the distance formula with because it is a diagonal line. So I would get 4 minus 2 quantity squared plus 2 minus 4 quantity squared. Okay, you would get 2 squared plus negative 2 squared, which is 4 plus 4, which is the square root of 8. And that is not equal to 3, so it is not isosceles trapezoid. Okay, that's that for that. Okay, so it says theorem 7.14, isosceles trapezoid base angles theorem says if a trapezoid is isosceles, then each pair of base angles is congruent. Okay, so you can see in this picture, I'm going to make it darker. Okay, those two would be congruent to each other, and then the bottom two that have 2 would be congruent to each other. Okay, can't really tell if that has 2. Make it darker. Okay. All right, theorem 7.15, isosceles trapezoid base angles converse. It says if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. Okay, so the difference between theorem 14 and 15 in this chapter, okay, it's telling you that this trapezoid is isosceles, so you can conclude that the base angles are congruent. Okay, this one is saying the base angles of this trapezoid are congruent, so you can say that it's an isosceles trapezoid. Okay, it works in both directions. All right, then theorem 7.16, isosceles trapezoid diagonals theorem. A trapezoid is isosceles if and only if its diagonals are congruent. Okay, and it shows you that in that picture. Okay, they should be congruent or the same length. Okay, so if you turn the page, it says the stone above the arch in the diagram is an isosceles trapezoid. Find the measure of angle K, the measure of angle M, and the measure of angle J. Okay, so I'm looking here. It tells me that it's an isosceles trapezoid, so I know that these are base angles and these are base angles. Okay, so I know that the measure of angle L is equal to the measure of angle K, so that would be 85 degrees. That's a K, sorry, it didn't turn out very well. Okay, so then I know that the measure of angle L and the measure of angle M together need to add up to be 180 degrees. Okay, so to find the measure of angle M, I'm going to do 180 minus the measure of angle L, which is 180 minus 85, and that will give me 95 degrees. So then the measure of angle M is the same as the measure of angle J, which is 95 degrees. Okay. All right, vocab, mid-segment of a trapezoid is the segment that connects the midpoints, hence the word mid-segment, of the legs. Okay, remember the legs are the non-parallel sides. Okay, so this is a midpoint and this is a midpoint here. Okay, and then you connect them and that makes a mid-segment. Okay, so theorem 7.17 says the mid-segment of a trapezoid is parallel to each base and its length is 1/2 of the sum of the lengths of the bases. Okay, so I'm looking at this picture here, MN is equal to 1/2 of AB plus DC, or CD, whatever. Okay, so then in example 3, it says in the diagram, MN is the mid-segment of trapezoid PQRS, find MN. So MN is equal to 1/2 of PQ plus SR. So I know that PQ is 12 and SR is 28. So 12 plus 28 is 40, 1/2 of 40, or 40 divided by 2, is 20, and it's measured in inches. Okay, you can turn the page there. All right, so find the length, the length of the mid-segment YZ in trapezoid STUV. Okay, so first I need to find the length of SV in TU. So find length of ST and VU. Okay, so SV equals big square root for distance formula, 0 minus 2 quantity squared plus 6 minus 2 quantity squared. That will give you the square root of 20. Okay, which is the same thing as 2 root 5. Then, oh, I wrote down the wrong thing earlier. ST, and it should be TU. My bad, not BU, TU. Okay, and now TU, and I wrote down S. Oh, I wrote the wrong thing completely. My goodness. Okay, find the lengths of SV and TU. There we go. All right, so SV is that. TU, my bad, is big square root 8 minus 12 quantity squared plus 10 minus 2 quantity squared. And there you get the square root of 80, which is 4 root 5. Okay, so then MN, remember, is equal to 1/2 of SB plus TU. Okay, so then YZ is actually what it's called, not MN this time. So YZ is equal to 1/2. SB we said was 2 root 5 plus TU is 4 root 5. Okay, and since these both have root 5s on them, those are like terms, and so I can add those together by simply adding the 2 and the 4 together. So that would be the same thing as 1/2 of 6 root 5. So 1/2 of 6 then is 3 root 5 units. Okay. All right, vocab here is a kite. So a kite is a quadrilateral that has 2 pairs of consecutive sides congruent. Okay, so you can see here in the picture, the bottom 2 are congruent and the top 2 are congruent. Okay, so then if we're looking at our theorems, if a quadrilateral is a kite, then its diagonals are perpendicular. Remember, that means that they form a 90-degree angle. Okay, you can see that there in the picture. Theorem 719, kite opposite angles theorem, says if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. Okay, and it's the 2 that are between the non-congruent sides. Okay, so you can see here that C and A, these sides are not congruent, so it's the angle in between them. These sides are not congruent, so it's the angle in between them. Okay, so in example 5, it says find the measure of angle D in the kite shown. So I know that angle D is congruent to angle F, okay, and I'm looking for D, so it doesn't really matter. I'm just going to call both of them X because they're the same. Then I see that I have 115 and I have a 73. Okay, and I know that this is a quadrilateral, so no matter what it is, it's going to add up to be 360 degrees. Okay, so then if I do that, I have 2x plus 188 equals 360. So then 2x, if I subtract 188, gives me 172. divide by 2, and you get x equals 86 degrees, okay, or the measure of angle D equals 86 degrees. Okay, turn the page. Okay, so you can see like this kind of like a hierarchy here. It says the diagram shows relationships among the special quadrilaterals you have studied in this chapter. Each shape in the diagram has the properties of the shape linked above it. For example, a rhombus has the properties of a parallelogram and a quadrilateral. Okay, so in example 6, it says, what is the most specific name for the quadrilateral ABCD? Okay, so the only thing that I know is that segment BE is congruent to segment ED, and segment AE is congruent to segment EC. Okay, that's the only thing that that picture is telling me. So what does that mean? So that means that the diagonals are being bisected. Okay, I can also tell just by looking at, obviously, it's a 4-sided figure. Okay, so I know it's a quadrilateral, so I can start here. Okay, is it a parallelogram? Okay, well, do parallelograms have diagonals that are bisected? Yes, they do. Okay, can I say that it's a rectangle? Does it have 4 congruent angles? No, I can't, so I have to pop back up to parallelogram. Then I pop down, okay, well, could it be on this direction? Could it be a rhombus? Does it have 4 congruent sides? Well, it looks like it, but it doesn't tell me that, so I can't assume that that's true. So I have to pop back up, and I'm stuck right here. So the most I can say is that ABCD is a parallelogram. Okay. All right, then if you turn to the last page, okay, something we can kind of fill in here. If we go through this chart here, it's just going to help you come back and maybe study it for it and see it a little bit faster than digging through your notes, okay? So the first one is a parallelogram. So can I say that both pairs of opposite sides are parallel? Yes, I can. So I put an X there. I can say that both pairs of opposite sides are congruent. Yes, I can. Okay, then I come down. The only couple other ones I can say is that the diagonals bisect each other. Both pairs of opposite angles are congruent, and consecutive angles, this very last one, are supplementary. Okay, well, the next one is a rectangle, and a rectangle is everything that a parallelogram is. And then what's special about a rectangle is that all 4 angles are congruent. So I can add that one, and the diagonals of a rectangle are congruent, so I can add in this one. Okay. A rhombus is also a parallelogram, so anything that had parallelogram, I can mark it. Okay, well, rhombus, what makes a rhombus special is that all sides are congruent and the diagonals are perpendicular. Okay, so I can fill those in. The next one is a square. A square is a parallelogram, a rectangle, and a rhombus. So anything that's been filled in to the left so far, I'm going to fill in for a square. So the first 2, these, and then the last 2. Okay, now I come over to trapezoid. Okay, this is just a regular trapezoid, nothing special about it. The only thing that I can say is that exactly 1 pair of sides is parallel. Okay, if it's an isosceles trapezoid, okay, then it's obviously a trapezoid. But then what makes it special is that exactly 1 pair of opposite sides is congruent. Okay, and the diagonals are congruent. Okay, and the last one is a kite. Okay, the only thing that we know about a kite is that the diagonals are perpendicular. So that's there. And that there's exactly 1 pair of opposite angles congruent. So that's 3 from the bottom, right there. Okay, so that is your chart. Use it how you want to help you study, or quickly look back to see what's true about a given shape.